Okay, this wants to solve this exponential e to the 1 over x equals minus e. Now, if you thought about that and someone said solve that, you'd say, I wonder what that looks like. Whoops, sorry about that. I made a mistake already. Let me put it axes down for you. And certainly if I looked at minus e, that's over here somewhere. And this is y equals minus e. All right? And then the question is, what's e to the 1 over x going to be? Well, if you thought about it, I mean, just you take some values. I'm going to say that, x can't be equal to 0. That's a given. And then you start to realize that, what's going to happen over here is that if you're in the positive values, if x is greater than 0, what's this going to look like? Well, when you go towards 0, this thing's going to be, e to the infinity, which is going to look like this over here. And then what happens when you start to get large numbers, it gets small, something like this over here. Now, I'm going to look at the other side of it. I'm going to say when x is less than 0. And what happens there? Well, let's take a look at it. When you go towards 0 from the left side, like negative numbers, you're going to get e to the minus infinity. So this thing's shooting off towards 0 now. All right? Then what happens when you start going the other direction, like towards the minus infinity, that's going to go towards the 0. All right, something like this over here. Now, granted, that's a rough picture. It's not an accurate picture, but it's good enough to know that this has no real solutions to it. All right, and one thing I'd recommend you do is, maybe use technology, and to realize that, you could easily graph out e to the 1 over x using technology to see what it looks like. All right, and by the way, I'm going to say it looks sort of like that. I'm not going to say it's a terribly accurate picture, but it's good enough. The reason I say it's good enough, I know there's no real solutions. So over here, what does it say to do? It says look for complex solutions. All right, and that's what I'm going to do. I'm going to go to the whiteboard and look for complex solutions. I can't visualize them, but I can certainly start thinking about what that would look like going to the whiteboard. So let me go to the whiteboard, and let me blow this thing up over here, and let me close this out, and let me get my pen back. Okay, good. So what I'm going to do over here, I'm going to write down the equation, which is e to the 1 over x equals minus e, and then I want to say that x is a complex number. All right. My question is, what do you have to do over here? I got to rewrite this guy so I can take the log of it, and I do want to take the log of both sides, by the way. And maybe I don't want to take log of both sides. Maybe I just want to get e to a power, e to a power. So the first thing I want to do is I want to try to imagine what that number minus e looks like in a complex plane. So there's a real number and there's an imaginary number. All right. And I'm going to say minus e looks like minus e plus no I. All right. Now, what does that look like? If I visualize that, this is called the argument. And the argument is going to be theta, and the point's over here. So this distance over here is going to be just e, and that's what's called the modulus of the problem. So the argument is pi, but it keeps repeating itself every 2 pi k, with the understanding k is some integer, all right, some integer. Could be 0, could be 1, could be minus 1, whatever. Keeps repeating itself. And the modulus, r, is going to be the distance from the origin, or the pole, to that complex number, which is, I'm looking at it, it's minus e plus 0I. And that distance is just a, all right? So I could rewrite this e to 1 over x. And the way I'm going to rewrite the complex number is, it's going to be r e to the r theta. I'm sorry, I theta. I'm sorry. All right, I want to write that down now. So what's the r? The r is e times e I. And what's the theta going to be? It's this thing over here. Let me write this down. It's pi plus 2 pi k. And that, again, the k can be an integer. Now I'm looking at this, and I want to write it so it looks like both sides are an exponential. 1 over x equals e. That's a 1 there, so I'm just going to add the exponents now. 1 plus I times pi plus 2 pi k. All right? What I'm going to do now, I'm going to equate their exponents. So 1 over x is equal to 1 plus I pi plus 2 pi k. All right? What am I going to do now? Well, I want to find x. So I'm going to take the reciprocals of both sides. So x equals, and I'm going to be careful over here. And part of being careful is, try not to make an error when I do this. And I always say there's always sometimes a copy error. But let me write this down. So it's going to be 1 over. And I'm going to write it a little bit differently. I'm going to write it as 1 plus, I'm going to pull out a pi. And then you're going to get 1 plus 2k. I can put the I in the end. Now, by the way, as far as I'm concerned, this is an answer to it. However, I've been told in lower level classes not to write numbers that way. I should write numbers in the form a plus bi. All right? So what I'm going to do is multiply the top by its conjugate, the bottom's conjugate, which is 1 minus pi. And that's going to be 1 plus 2ki. Now, if you multiply the bottom, multiply the top by the same thing. The top is the easy one to do. And I'll do that right now. And what are you going to get? On top, you get 1 minus pi, 1 plus 2k, I. That was pretty easy. And then what do you get in the bottom? Let's take a look at that. These are conjugates. I want to point out what I mean by conjugate. If I have a plus bi and a minus bi, if I multiply that, I get a squared, and then you would get, the minus abi plus abi disappears. You get minus bi squared, which really translates to simply a squared plus b squared now. So I'm going to write that down. What's the a squared is 1, and the b squared is going to be pi squared, 1 plus 2k squared. Again, if you want to write it in the form, again, I'm going to say this is also a good answer as far as I'm concerned, but if you want to write it, by the way, again, the k could be any integer. If you want to write in that a plus bi form, what's it going to be? 1 over 1 plus pi squared, 1 plus 2k squared minus pi, 1 plus 2k over 1 plus pi squared, 1 plus 2k squared I. And that would be the a plus or minus the bi form. Right? Any answer is fine as far as I'm concerned. I can't say one is better than the other. If I had a preference, though, I probably would write this answer down. It's the quickest one to do. Some people don't like that written down that way. They write this one. And some people want it to split into 2 parts where they know what the A is and the B is. And we're done. Thank you.